Welcome to part 4 of lenses and mirrors. We were looking at the convex mirror. Just remind ourselves, put an object here. This line is the angle of incident equals the angle of reflection, and if we bring something into the that is parallel, it gets focused by the focal point and we can construct the image. And we describe it: virtual, upright and diminished. All virtual images are upright. Virtual images can be seen in the mirror. Remember, we can use a range of different lines. And it'll still come to exactly the same conclusion. My advice would be to use two that you're very, very aware of and comfortable, but know the other rules associated with it. What about some of the uses that we have for these types of mirrors? The security mirror in the shop are convex and spherical. This shows the image, say in a corner shop, grocery shop, and we need to describe the two features of an image inside the security mirror. So the image is virtual because we see it inside the mirror. It is clearly the right way up, and it's clearly smaller than the true grocery shop. Draw a ray diagram to show how this image is formed. So, straightforward. We draw the object. Could represent any of these objects in this. We just use it as an arrow. If we draw this line and we focus it through the focal point, remembering to put our arrows on here and the dotted lines here, and the second line we bring in is this one here, and we dot it back. Where these two things cross is where our image is. So, continuing our story of the uses of concave and convex mirrors. This came up a number of years ago, where we had to sort of compare and contrast these different types. So here's a flat mirror, and we're looking at a convex mirror. So what we do is we put a normal in, which is effectively 90 degrees to the mirror, whereas this would be 90 degrees to the tangent here. Remember, light rays go into the eye. It's not like the X-Men, where it comes out of the eye and goes out. A lot of people made a mistake with that. And the advantage has got to be how wide an angle we can see. We're clearly showing that the angle of incidence equals the angle of reflection, and similarly, but this is at this tangent point, a similar thing occurs. So your field of view is what we call. We can take light from here and bring it into the eye, so you see a lot more. And you get a merit for fully understanding and drawing that properly. Concave mirrors, they have this ability to focus things at a point. We use this type of mirror for car headlights. If you have a light here, it would obviously come out and go straight, whereas this is in communications. Very useful because they produce real images, so they focus beams onto a location. So things like telescopes and satellites use this principle. We've looked at security cameras and safety features on roads. So if you're coming out of a difficult junction, you can have a much wider field of vision. So you give you a small image for very large scenes. Security or dangerous intersections are the crucial places that you see it in everyday life. The concept of lateral inversion we'll look at in another video.